of a control grid which is present just ahead of cathode. Then we have electron gun. So, once those electrons are brought to a uniform velocity, then these electrons are accelerated. Why they are accelerated? Because the light will be emitted only when fast moving electron will strike with the phosphorus coating. So, this electron beam which is generated and consequently the electrons which constitute this electron beam should be moving at a velocity which is fast enough to cause an illusion or a light information on the phosphorus coating, or the kinetic energy associated with the electron should be so high that when they strike with the phosphorus coating a light should be emitted. So, with this accelerating anode the velocity of electrons is increased. Then we have a focusing anode. The purpose of providing focusing anode is this, that when electron beam moves it is in the shape of a tube. So, when these fast moving electrons which are in the shape of a tube strike with phosphorus coating, they will form a bigger spot and the bigger spot will not be having that much clarity. So, to get maximum output of the out of available electrons at a particular instant, what we require? We require that they should move with enough velocity which is ensured with the accelerating anode, and all of the electrons should strike at a particular location at a particular instant. So, that maximum output can be generated out of the number of electrons available at a particular instant. So, to ensure this we use this focusing anode which enables this electron beams and electrons which are present in this electron beam to strike in the form of a point, not in the form of a spot. So, this all these electrons are made to strike at the same location at a particular instant. So, that maximum energy could be generated out of the available electrons at that particular moment. Then we have deflection coils. The purpose of deflection coil is to deflect the beam spot in various directions. Those directions are left to right and top to bottom. So, when this electron beam moves, these electrons move from left to right under the effect of deflection coil, and current flowing in deflection coil has two types of coils, horizontal deflection coil and vertical deflection coil. So, current flowing in horizontal deflection coil will enable this electron beam to move in horizontal direction, means left to right, and current flowing in the vertical deflection coil will cause this beam spot to move top to bottom, that is in vertical direction. Here we have the phosphorus coating. When the fast moving electrons strike with it, light is emitted. Then we have here final anode. This is also called aqueduct coating. Here high positive potential is provided, so that the secondary emitted electrons are not available in the drift area and they will move over to the final anode. So, that they are immediately eliminated from the arena and they do not interfere with the incoming electron beam. So, this is ensured with the help of this EHT, and this is all covered in a glass enclosure. The beam is deflected by a pair of deflecting coils mounted on the neck of the picture tube in the same way and rate as the beam scans the target in the camera tube. So, this is very important. When you have to display the picture, we can display only that picture which we have picked. So, picture is picked in the camera tube. So, in the same fashion, in the same manner as the picture has been captured, in the same way it is being displayed. So, the rate is same and the collection process is also same, means if it is left to right, it should be left to right in the receiver also. The amplitudes of current in the horizontal and vertical deflecting coils are so adjusted that the entire screen called raster gets illuminated because of the fast rate of scanning. So, scanning is done at a very fast rate and the amplitude or the strength of horizontal and vertical deflection coil current should be sufficient, should be high enough to generate a large amount of deflection which moves the beam spot from left to right and from top to bottom. So, that whole of the raster, whole of the screen can be scanned. Scanning. Now, what the scanning is? The scene is scanned rapidly both in horizontal and vertical direction simultaneously to provide sufficient number of complete pictures or frames per second to give the illusion of continuous motion. So, this is illusion of continuous motion is also called illusion of continuity, means the scene is to be displayed in such a manner at such a fast rate that we are not able to judge that whether it is still picture or it is moving picture. So, that rate should be fast enough. So, that is done with the help of a very fast rate of scanning, and then we also show it at the same rate. The scanning is process performed in picture tube to convert optical information into electrical signal. So, optical information is to converted into electrical signal with the help of scanning. So, that process of moving electron beam from left to right and top to bottom and getting information of every spot at every instant is the process which is called scanning. In that process, we convert optical information into corresponding electrical signal. The fine and sharp electronic beam is used to scan the focused image and beam convert optical information to electrical signal element by element and line after line till entire picture or image is scanned. So, entire picture or image is scanned means when picture or image is scanned, then beam spot moves moves over entire the area, and it does simultaneously, means it moves left to right, it moves top to bottom, and it covers whole of the screen or whole of the scene or whole of the face plate which is having a conductive coating. So, electron beam moves left to right and moves top to bottom, and it covers all the areas and gets information from all the areas. Scanning of the element is done at a very fast rate, and this process is repeated a large number of times per second to create an illusion of simultaneously pick up and transmission of picture details. So, picture details are picked up and transmitted. How they are done? That if we have to create an illusion of continuity, then scanning must be done at a very fast rate. So, this is done. Scanning may be defined as a particular process which permits the conversion of information existing in space and time coordinates into time variations only. As we already have discussed, time variations only means the picture is a function of space and time, and with the help of scanning we get electrical signal, and electrical signal of a particular time means the information which is optical is converted into electrical signal, and it remains time variation only. The electrical information obtained from TV camera tube is generally referred to as video signal. As we already have discussed, that video signal is the signal where where the electrical signal has been generated from the optical information. This is how scanning takes place. This is raster. We take the case of Indian system 625 line system. In this system, what we have here is the trace period and this is the retrace period. Trace period and retrace. A sawtooth wave is generated. This is the current which is available in the horizontal and vertical deflection coils. For horizontal, this is horizontal. For horizontal scanning, this is current available in horizontal deflection coil. When current rises, the beam spot moves from left to right, and it is called trace time or it is called trace period. When beam spot moves from right to left, that is in reverse direction, then it is called retrace. This is called retrace period. So, this sawtooth wave is trace and retrace, means when the direction of current is rising, beam spot moves from left to right. When direction of current reverses, the movement of beam spot will also be reversed, and instead of moving from left to right, now it will start moving from right to left, and this is called retrace. So, during retrace no picture is picked up and no picture is displayed also. This process is similar to the process as if we read a book. We read a book from left to right. When we read from left to right, what we do? We read all the words which are written in the book, and that is what? That is tracing. The image of those words is created on the mind, and when we move from, when we finish a line, we move from right to left, we do not read any word. So, no information is picked up. So, in similar fashion, when we move from left to right, the information is picked up, it is called trace, and if it is picture tube, the information is displayed, it is called trace. When we move from right to left, it is retraced. During this, no picture information is picked up and no picture information is displayed. This shows vertical scanning. In vertical scanning, what happens? The beam spot is moved from top to bottom, top to bottom. So, here when current rises, the beam spot moves from top to bottom. The beam spot is under the effect of a force which enables it to move from top to bottom. So, both these forces of horizontal deflection coil and vertical deflection, as current is present in both the coils, horizontal deflection coil and vertical deflection coil simultaneously. So, current flows in both of them. So, beam spot moves from left to right. At the same time, there is a force available which makes this beam spot moves from top to bottom also. So, under the effect of both these forces, beam spot moves from left to right, but with some angle, as it is seen from here with some angle, because it is under the effect of both the forces, force which is exerted from top to bottom and force which is exerted from left to right. So, here we are concerned with vertical scanning only. So, it means when the current rises in horizontal, in vertical deflection coil, beam spot will move from top to bottom, and when the direction of current is reversed, means when the current will direction of current is reversed like this, when it is falling, then beam spot will move from bottom to top. So, when beam spot moves from top to bottom, this is called vertical trace, as it is here trace period. This beam, this area, when it increases, this is called vertical trace. When this current is falling, then as it is falling here, it is called vertical retrace. In this period, beam spot, after finishing the scanning of one frame or one field, it will move back from bottom to top. So, its vertical movement will be like this, from bottom to top. This is called vertical retrace. So, this is vertical trace and this is vertical retrace period. Horizontal and vertical deflection scanning taken together, the current is increasing in vertical deflection coil and here it is decreasing in vertical deflection coil. Here when current is increasing in vertical deflection coil, in horizontal deflection coil it is increasing and falling, rising and falling, rising and falling. So, in this way, in one go of vertical trace, there will be number of horizontal trace and retrace period. It means when beam spot moves from top to bottom, during that duration it will move from left to right number of times. So, this shows vertical trace and this shows horizontal trace, this shows vertical retrace and this shows horizontal retrace. So, in one vertical trace there are number of horizontal trace and retrace intervals. Next is flicker. Although the rate of 24 picture per second in motion picture and that of scanning 25 frames per second in television picture is enough to cause an illusion of continuity, they are not rapid enough to allow the brightness of one picture or frame to blend smoothly into the next through the time when the screen is blanked between successive frames. This results in a definite flicker of light. Flicker is means when light is turned on and off, and when it is done at a very fast rate, you say that this is flickering light. So, flickering light means similarly a flicker can also exist in a television system, because this rate of scanning 25 frames per second is enough to cause an illusion of continuity, because the 1/16 is the time period for which a particular picture is there on the in the retina of the eye. So, if a picture is removed and similar picture is replaced before that interval, then that may cause an illusion of continuity as if the picture has moved to its new location. So, this process is called illusion of continuity. So, that illusion of continuity or that limitation of human eye is exploited to cause an illusion of continuity. So, this rate of 25 frames is enough to cause an illusion of continuity, but at the same time this rate is not enough to allow the brightness level of one frame to smoothly blend over the brightness of the next frame. So, this is called a flicker. So, we stop here and we will continue next time.